So hi everyone guys, I'm Swapnil and welcome to yet another video session with PrepBytes. In today's video tutorial, I would be discussing the problem Flying Beast of the February Marathon 2021. Let us get started with the problem statement. The problem statement says, Flying Beast is a famous Indian YouTuber. Recently took courses of data structures and algorithms on PrepBytes. While practicing, he got stuck in a problem. Since he is new to coding, we will have to help him to solve this particular problem. Okay, now the problem goes like, given an array A of size n which consists of elements 1, 2 up till n, we will have to find sum A. I am parallelly writing the important points for this problem so that it would be easy for you to understand. So my array A is given in this way, which is 1 to n. Okay, now sum A is defined as summation of maximum S minus minimum S for each and every subarray S of array A. Okay. And max S and min S are nothing but maximum value in that particular subarray of array A, and minimum of S is the minimum value of that particular subarray of array A. Okay. The input format is like the first line contains an integer t which denotes the total number of test cases, and then the first line of each and every test case contains a single integer n, which is the size of the array and for which we will have to find summing. Okay, output is for each test case we will have to print a single integer representing the answer for that particular test case. Now the constants are t can range from 1 to 10 and n can range from 1 to 10 power 5. The time limit for solving this particular problem is 1 second, and this is my example input and output. Let us move to the coding area and understand this particular problem in a better way. Okay, so now we will be discussing the sample test case for the case when n is equals to 5. Okay, so when n is equals to 5, my array is nothing but 1, 2, 3, 4 and 5. So we can see the sub arrays of this particular array is nothing but 1 2 3 4 5, then 1 2 2 3 3 4 4 5, and then 1 2 3 2 3 4 3 4 5, and then 1 2 3 4 and 2 3 4 5, and the final is nothing but the same array 1 2 3 4 5. Okay, now let us see each and every subarray closely. We can see that the contribution of all the single sized subarrays is 0, all the two sized subarrays is 1, and all the three sized subarrays is 2, and all the four sized subarrays is 3, and all the five sized subarray, which is nothing but the array itself, is 4. So let us look at these particular numbers closely. So for single size subarrays, the minimum and maximum values are the same, so the contribution is 0. For the size 2 subarrays, the minimum and maximum is nothing but in a gap of 1. So 2 minus 1 would be 1, 3 minus 2 would be 1, 4 minus 3 would be 1, 5 minus 4 would be 1. For size 3 subarrays, the gap would nothing but be 2, because 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is again 2. For size 4 subarrays, the gap between the highest and the lowest element is nothing but 3, and the gap in the 5 size subarrays, which is size is equals to n, for that the gap is nothing but n minus 1, right, which is nothing but 4, because 5 minus 1 is 4. So we can see over here that these particular numbers form a pattern. Added to this, the total number of single side subarrays, it's nothing but the size of that particular array. Because what is this single side subarrays? They are nothing but the elements itself, the elements of the array itself. So the number of single side subarrays is nothing but n. Okay, so let us make a table of size of subarray and total number of such sized subarray of A of size n. Okay, so it would be nothing but there would be two columns. Let us say this is the size column and then this is the number column. So if the size of the subarray is 1, then obviously total number of such subarrays would be nothing but n. if the size of my subarray is 2, then total number of subarrays would be nothing but n minus 1. And this goes like if the size of the subarray is nothing but n itself, which is the array itself, then such size subarrays is nothing but 1 only. So this is the pattern over here. Okay. So for single side subarrays, my contribution is 0. So total it would be n into 0, and then n minus 1, which is the total number of size 2 subarrays. Then the contribution over there would be nothing but 1. So n minus 1 into 1, and it would go till the n size subarrays, which is nothing but 4 in number, which is how 4, which is nothing but n minus 1. The contribution is n minus 1, and there are total 1 such size subarray. So it would be 1 into n minus 1. So we can see that the formula for n is equal to 5 is coming out to be 0 into 5, because there are 5 such subarrays single sized. 1 into 4, you can see 1 2 3 4, and then 2 into 3, and then 3 into 2, and then 4 into 1. So if we generalize this for the n size subarrays, we will have n subarrays of size 1 with 0 contribution, n minus 1 subarrays of size 2 with 1 contribution, n minus 2 subarrays of size 3 with 2 contribution, and it will go till 2 subarray with size n minus 1, and it will be having n minus 2 as their contribution, and 1 subarray with size n with n minus 1 contribution. Contribution is nothing but the difference. Okay, so the formula comes out to be 0 into n plus 1 into n minus 1, as I explained over here. 0 into n, n minus 1 into 1, and then n minus 2 into 2, and then n minus 1 into 1. So this is my formula which is coming out from above analysis. So this can be written as summation of I into n minus I, where I is going from 0 till n minus 1. You can see it's the same. This expression can be written as this. So let us break these particular brackets, and it would be nothing but summation of n into I minus I into I, where I is equals to 0 to n minus 1. So this particular quantity can be written as n into summation of I, and this particular quantity can be written as summation of I into I, where I is from 0 till n minus 1, right? Now the summation of I is nothing but n into n plus 1 by 2, and summation of I square is nothing but n into n plus 1 into 2n plus 1 by 6. So that's what we have written here for n minus 1. It's n into here n minus 1 into n minus 1 plus 1 by 2 minus n minus 1 into n minus 1 plus 1 into 2 into n minus 1 plus 1 by 6. After like evaluating this particular expression algebraically, we will be getting this particular formula, which is nothing but n into n minus n by 6, which is n cube minus n by 6. So for each and every input n, we will have to output n cube minus n by 6. So this is the basic pseudocode. Now I will show you the C++ implementation, which is very easy. Here we have taken t as the total number of test cases, and for each and every test case I am taking n as input, and I am printing n into n minus n by 6 as my output. And I have declared hash define int long so as to take care of the larger numbers. So let us see if this is working fine for the sample test case. We are compiling it. Let's now run it. Yeah, it works fine for the sample test case. Let me remove this free open lines and submit this particular code in the PrepBytes platform. Okay, now let us run this code first. Okay, so it ran successfully and giving correct output. Let us submit this one now. Okay, so you can see that we have got an AC for this solution. Thanks for watching this video and keep coding.